Now we want to find the area of this triangle. And the area is equal to 1/2 base times height, which is 1/2. I don't know what A is, but I do know what the height is. It's equal to 2A. And if I know what A is, I'm in great shape. And I also know this. The best thing to use here is tangent, because the tangent of 30 degrees, which is opposite over adjacent. And the tangent of 30 degrees is equal to the sine of 30 degrees over the cosine of 30 degrees. I know the sine of 30 degrees is 1/2, and I know the cosine is the square root of 3/2. If I multiply this by 2/2, I get 1 over the square root of 3. And if you want, you can rationalize this to the square root of 3/3. However you want, all these answers are correct. 4/A is equal to, I'm going to use this one, and then I can say 4 times the square root of 3 is equal to A. And now I can go back and say that my area is equal to 2 times A, and A is 4 times the square root of 3. So it equals 8 times the square root of 3. And that's pretty much it. As long as I have a right triangle, I just use my basic trig functions. Consider the sinusoidal function f of t equals 9 cosine of 2 pi t minus pi/2. Find each of the following. The amplitude. Let's kind of break this down. If we have f of t, that's going to equal A, which is the amplitude, times, it doesn't really matter what the trig function is. For this one, we'll just call it cosine. This is omega t minus theta, where A is the amplitude, and it's always positive, so it's really the absolute value of A. Omega is the angular frequency. Theta is phase angle. The period is equal to the original period, which was 2 pi, divided by omega. And the time shift is going to equal theta over omega. Basically, we're factoring it out. The easiest way to say this is, this I should write as 9 cosine of 2 pi times, if I factor out a 2 pi, this is t. I basically am dividing this by 2 pi and this by 2 pi. That becomes t minus 1/4. This is what we call in math the shifted form. And some things we can find easier from the shifted form, and some things we can find easier from the original equation. Having said all that, my amplitude is the number in front of the cosine. So that's 9. My angular frequency is the omega in front of the t. Here, for that, I can say it's 2 pi. My phase angle is going to be 1/4. My period is equal to 2 pi over omega, and I know omega is the angular frequency, which is 2 pi. So my period is equal to 1, and my time shift is this value here, which is 1/4. The plot below shows the graph sinusoid of the form. I know it's the sine because if I were to draw a unit circle, this point right here is 1, 0. So at 0 radians, my sine is 0. So sine always goes through the point 0, 0. And cosine will go through the point 0, 1. Because obviously at 0 radians, it's 1. I always start sine at 0 and cosine at 1. Unless, of course, I've shifted it. But I can tell this isn't shifted because I'm starting my sine at 0 and it's going up. If it was going down, like if from here it was going down instead of up, I would know I have a negative sign. Let's write our function. We have f of t. And we need a, the amplitude. What's the amplitude here?
2.
Perfect. And then I have sine. And then I have to find omega. How do I find omega?
Would that be, you find like the period, which is 4, and then
Good.
that'd be.
So wait, let me write it. So period new, which is what I'm trying to find, because if it was the same as the old period, it would be 2 pi, right?
Right.
So equals the original period, which is 2 pi over omega. The new period, because we can see it. It starts here, just like you said, it ends at 4, and then it starts again. So I have 4 is equal to 2 pi over omega, which means omega equals 2 pi over 4, which is equal to pi over 2. Now I have pi over 2 times t, and I don't have any shifting right or left. We know the amplitude, a equals 2, omega equals pi over 2, and phase angle equals 0. You know what? We can do this in a shifted form. If I call it a cosine, then it's shifted. I'm going to now write g of t. And my amplitude's still the same. But if I call it cosine, then what I'm going to do is I'm going to say pi over 2 times t. And again, this point right here should start here, shouldn't it? If it was cosine. I've shifted it to the right by 1 because that's 2. I shifted it to the right, which means I subtract 1. And now it's in that shifted form I was talking about. And I can multiply it out. I can say this is equal to 2 cosine of pi over 2t minus pi over 2. And now I know my phase angle. This is exactly the same as this. It's exactly the same graph. One's using sine, one's using cosine. When it's using cosine, I've shifted it. Write a single sinusoid of the form blah, 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 that has an amplitude of 8, a period of 3, and a time shift of 1. So I would have f of t. I know my amplitude is 8. Sine. I don't know omega, but I do know my period, and I know my new period, which is 3, because it's not 2 pi, so it's got to be a new period, which equals 2 pi over omega, which means that omega equals 2 pi over 3. I have 2 pi over 3t, and time shift is 1. Again, if I'm doing a time shift, the best thing to do is shift it by 1 like that, and then you could multiply it all out. I have f of t is equal to 8 sine of 2. If they want it in this form, then I have to distribute it minus 2 pi over 3.